So we're going to go back to where we have h written in that factored form. Okay, so this is how I had it. So replace s with j omega as we did before, and then it says find the angle for each linear factor and also for the constant factor. For the constant factor, if it's a positive real number, then the angle is 0. If there's a j in the constant term, then you're right on the imaginary axis, which means you're either up at 90 or down at -90. So what about the other linear factors, the 1 plus j times omega over a? So it says use inverse tangent to find the angle for that factor. So 1 is on the real axis, and then omega over a is on the imaginary axis. So to find the angle for that factor, we just want to use inverse tangent, right? So I drew my right triangle. Here's 1 on the real, omega over a on the imaginary, made that right triangle. So tangent is opposite over adjacent. And then we just take inverse tangent. So opposite is omega over a, adjacent is 1. And so you just get inverse tangent of omega over a. So do that for each factor. And then remember, so this is just like phasors. When we wrote everything in phasor form, the phase angle was you took all of the angles from the numerator and added them together and then subtracted all of the angles for the denominator. So same exact idea here. Okay, so the j omega is better because remember this j omega, when we squared it, we got negative omega squared, and then we can put the negative with the 10 to the 7th, and now it's a negative real number. So we're over on this axis, which means the angle is 180. And then here, so it says we're doing this for each factor. We're going to add and subtract the angles for each factor. But if a factor is raised to a power, then we take that multiple of the angle. So here when I have omega squared, first I just find the angle for omega. And then if I have 2 of those factors, that basically means I have that angle twice in the numerator. I have it once for the first omega and then again for the second omega, and then I add those together, right? So for the whole term, if we include the squared, that's going to make it 2 inverse tangent of omega. Okay, now in the denominator, so I'm going to use kind of the same idea for this term because it's squared. So if I just focus on the part inside parentheses, it's going to be inverse tangent of omega over 10 to the 4th. And then since that factor is squared, I use that angle twice. So if I look at the whole thing, I have 2 tan inverse of omega over 10 to the 4th. And then the last term, it's not raised to a power, so I'm just using inverse tangent of omega over 10 to the 3rd. So the phi, that is our overall phase from the constant term. So at first I'm going to add up the angles in the numerator and then subtract the angles in the denominator. So the first term in the numerator, its angle was 180. Plus, because there was one other factor in the numerator, and that was the 2 inverse tangent of omega. Now I'm going to start subtracting because I'm looking at stuff in the denominator. So the one in green, I had the first factor squared, so I'm subtracting 2 of those angles. So minus 2 inverse tangent omega over 10 to the 4th. And then subtract that last angle, inverse tangent of omega over 10 cubed. Okay, so there's our phase. Just like with the magnitude, we want to do term by term. So I'm going to really have, first, I'm going to graph the 4 terms separately, and then I'll look at taking the sum at the very end. So I'm just going to call this one will be my phi 1, and then I'm just going to call this whole thing phi 2, and then the next one I'm going to include the negative, call that phi 3, and then the last one include the negative and call it phi 4. So I'm going to graph each of the 4 separately and then, do the sum for my final graph. And then I'm going to use some guidelines given in the book. So this is from table 15.1 on page 1043. And I'm just going to use the 3 highlighted ones. So when your input is 0.1, this omega naught is the denominator. Okay, I've called it A in my steps, but you just look at the denominator. So if you're 1/10 of the denominator, you're just going to have a horizontal line at 0. When you're right at the denominator, well, if you have A over A, that's inverse tangent of 1. Where does tangent equal 1? At 45 degrees. So when the input is the same as the denominator, then you're at 45. They're saying negative. We'll deal with that later. Just so think of if your numerator is the same as your denominator, that's 45 degrees. And then we'll look at whether we're adding or subtracting. And then if you're 10 times the denominator, their approximation is, we're just calling that 90. Okay. So let's go back here. This first one, that's just a constant term. So it's always at 180. So I'm going to, and I have another semi-log scale down here. Okay, so first I just want to graph 180 all the way across. Okay, now for the next one. So you're at 0 until you get to 1/10 of the denominator. So now I want to look at phi sub 3. I'm going to just do it under the graph. Okay, so phi sub 3. So we have, and that one's being multiplied by -2. Well, first we're going to worry about when it's 0, and then when the inverse tangent part gives 45, but we're going to multiply that by -2, and when the inverse tangent part gives 90. Okay, so when is it 0? When the numerator is less than or equal to 1/10 of the denominator. So it's 0 when omega is less than or equal to 10 to the 3rd. Right? It's -2 times 45 when the numerator equals the denominator. So when omega equals 10 to the 4th. And when is it 90? It's when the numerator is greater than or equal to 10 times the denominator. So that would be 10 to the 5th. Okay, so I want to kind of plot 3 points, and then there are going to be 2 horizontal pieces and then like a slanted piece. Okay, so it's 0 until 10 to the 3rd. And then when omega is 10 to the fourth, we're at negative 90. So here's 10 to the fourth, negative 90. And then starting at 10 to the fifth, we're negative 2 times 90, which would be negative 180. So by the time we get to 10 to the fifth, we want to be at 180. And then it's just going to, negative 180. Then it's just going to stay negative 180. Then I'm going to join those 3 dots. And then before it got to the first dot, it was 0. Okay, one more term left. The phi sub 4. I'm going to do that under the graph as well. Okay, so phi sub 4, and there are 3 key values. So 0, and then 45, but we're multiplying it by a negative, and 90, but we're multiplying it by a negative. It's 0 when omega is less than or equal to 1/10 of the denominator. And if the denominator is 10 to the third, 1/10 of that is 10 squared. It's equal to negative 45 when the numerator and denominator are equal. So that's when omega equals 10 to the third. And then it's at negative 90 when omega is greater than or equal to 10 times the numerator, or greater. And so if the denominator is 10 to the third, 10 times that is 10 to the fourth. Okay, so I want to now go to the graph and kind of plot 3 important points. It's 0 at 10 squared, and everything below, but I'll take care of that in a minute. It's at negative 45 at 10 cubed. So here's 10. There would be negative 50, negative 45. And then at negative 90 for 10 to the fourth. So here's 10 to the fourth, and then there's negative 90. So I want to join those 3 dots with a line. And then it's horizontal before 10 squared and horizontal after 10 to the fourth. Okay, now like with the other graphs, we want to add up the 4 terms and we want to identify all of the corner points. And then at 10 squared, the pink graph has a corner, and then at 10 cubed, the green graph has a corner. And the orange graph never has a corner. So we've identified those 3 corner points. Okay, I was being silly. The phi 2, I put a note in the video, but the phi 2, there was no j in that term. There's only an omega. The other ones had a j inside parentheses. After I squared, I got rid of the j. So omega, that's just the frequency, which is a real number, and it's positive. So we're always on the positive real axis, which means the angle is 0. So that graph is just a horizontal line at 0 the whole time. So then we really only have the 2 corner points at 10 squared and 10 to the third. So when I'm adding up all of the function values at 0, I just have 3 values that are 0 and 1 that's a 180. So I'm just up at 180. And I stay there until I get to 10 squared. So put my 2 dots there, join them with a line. Okay, now my first corner point is at 10 squared. That's fine. Our next, I already have that point. My next corner point is at 10 cubed. So this one, we're still at 180. 2 of the function values are 0, and this one is negative 45. So 180 minus 45 is 135. So when we get to 10 cubed, we should be down at 135. So here's 10 cubed, 130, 135, about, and then join those with a line. Okay, next corner point is at 10 to the 4th. And so we're just going to add up all of the function values there. So this one is still 180, this one is still 0, and then 2 are at negative 90. So the green is at negative 90, and the pink is also at negative 90. So I have 180 minus 90, which would be 0. So by the time we get to 10 to the 4th, we're down at 0. Connect those two dots with a line. And then I'm just going to do the point on the edge. Okay, which for me is at 10 to the 6th. So this one, we're still up at 180. This one's still at 0. This one's at negative 90. And the green is at negative 180. So the positive and negative 180s, those cancel, and what I'm left with is negative 90. And that was at 10 to the 6th, so we're down at negative 90. And then join those two dots with a line. Okay, and then I'm going to go look at the book's answer, compare. Okay, so starts at 180, it stays flat. Let's look at our 10 to the 3rd values. So I'm up here at 135. 10 to the 3rd. It's really hard to tell in this graph. There's like halfway between would be 90. So it looks like I'm about halfway between 90 and 180. So that seems reasonable. The answer says it's 0 at 10 to the 4th. Yep, that's what our graph, that's what we have, 0 at 10 to the 4th. And by the time we're at 10 to the 6th, we're down at negative 90. And then here at 10 to the 6th, yep, halfway between 0 and negative 180, and then it just basically stays there. All right. I know that was a lot. Good luck.